So we are officially being recorded. And as always, we will start with questions. Anything that you guys want to ask before I get underway?
So for homework this week, there's just that one file in lesson 12, right?
What I want to do is back up to lesson 11. I wasn't happy with my presentation in our last class period. It was too fast. It was yucky. So we're going to do a little bit more of 11.
Okay.
And
But the 12 will still be due on Monday, right? The 12 homework, and there'll be no homework in the 11.
No, I think I want to give you some lesson 11, and I was just working on that. So let's take a look at what's in the folder right now. So I've got two problems for you. I've got the wedge problem, and I've got a bar problem. And then I put a couple of these other class examples that I want to show you right now. I think that's going to make things much, much clearer. So let's get underway with that. And then by the end.
So going forward, when we submit stuff now, we should have always a drawing as well as a SolidWorks part piece.
For the next couple lectures, yes. So we're covering piece part drawings right now, which are drawings of just single solid models. When we get done with probably the next 3 or 4 lectures, then we're going to go on to assemblies. And we're going to start putting all of these single pieces together into much bigger machines. And then we're going to come back and we're going to do assembly drawings. And we're going to teach people how to put our stuff together the way we want.
And then we have that makeup quiz on the 14th. So that's next Wednesday.
Correct.
Okay. And so we'll still work on 12.
Yeah,
So,
I'm gonna do 12 tomorrow.
Okay, cool.
And then hopefully I can get us back on track and we'll be good to go. But the students have told me in past years that this drafting stuff is the newest and strangest and weirdest stuff. So if I need to take a little extra time with it, I would rather do that. Okay, so we're gonna back up. We're gonna do a real simple plain Jane vanilla kind of problem. So what I'd like you to do is in lesson 11, download class example access cover. And you should see something that looks like this. Okay, so we're going to make a drawing of this access cover. So we're going to say File, Make Drawing from Part. We'll choose our piece part template so that we bring in the border and our format. And if all goes well, you should see something like this. Okay, the first thing I want you to notice is if I grab the front view and move it around, they all move together. That's important. Okay.
I'm sorry, which one of the examples were you supposed to grab? Because there's multiple ones. Class.
Yes. Grab access cover in lesson 11. Okay, Emmanuel.
Yes.
What did you need me to say again?
It's okay. I just missed whatever you said in the beginning. It's okay.
Okay. Yeah, there wasn't a lot of content. Just we're going to go over a basic example. We're going to kind of back up. I want to make sure everybody's on the same page and everything's,
okay.
you know, We're just going to cover the basics one more time.
Okay.
Okay, so we got this access cover. And everything moves together as it should because this is following the glass box rule. Great. So I'm going to get rid of the isometric because I want to put it over here and it was locked to this front view. So to create a new isometric, I'm going to say insert drawing view and I'm going to project a new view. I'll choose my front view and I'll put it up over here. I'm going to click on that isometric view. The rule for the isometric view is we always want to have the hidden lines turned off. So I'm going to come over to the view options palette and I'm going to do hidden line removed. That gets rid of all of the hidden lines.
For some reason, when I went to do the make the drawing, like it just came up with a blank drawing.
Okay, so that means that your format is probably not mapped properly under the options. So we'll have to square that away after class. Make sure that when you do say make drawing, you get something like this.
Could you do the projected view again, please?
Sure. We'll get rid of the isometric. So it's insert, drawing view, and project it. And we're going to project this front view. I'm dragging up at about a 45-degree angle, and I click to drop the view. I want to turn off the hidden lines, so I click on the view. I come over to the menu palette, and I come down to display style, and I say hidden lines removed. Okay, typically the isometric, it's just a visualization aid. So we don't need to follow the scale of these orthographic views. So I'm going to make it a little bit smaller so it doesn't take up as much room. So I'll choose use a custom scale. Instead of half scale, I'll make it quarter scale. Okay. And let's see. I don't need the top view. Because I can fully define the object with just these two views. Okay, when you're making a blueprint, always think about the next person that's going to use this. So you're probably going to take this thing, you're going to hand it off to a machinist. You're going to say, make me however many of these. The first thing the machinist is going to want to know is, how big is it? How big a chunk of metal do I need to cut this part out of? So the first logical thing to do is put the overall dimensions on it.
I'm gonna throw it out when I get up.
So I'm going to choose Smart Dimension. I'll choose the outside width, the overall height, and the thickness. Okay, so that defines how big a chunk of metal the machinist needs to go find. Okay, now we'll start doing some of the other features. So we need to size the features, we need to locate the features. It's conceptually a lot like the modeling that we did. First thing I'll do, I think I'll size that corner radius. So we're going to put a 1/2-inch fillet on the corner. Now we need to tell the machinist what kind of holes we want. So we're going to do that with a hole callout. Again, insert annotation, and we're going to come down to hole callout. I'll click on the hole, and because I was really slick and used the hole wizard, I get this really nice callout. which tells me exactly how to make the hole. Okay, so that defines the shape of the 4 holes. Now we've got to do the location of the 4 holes. I always encourage you guys, go off an edge that the machinist can touch. They're going to use this thing called an edge finder. So rather than going off something like a theoretical center line or something like that, go to something they can actually touch. Okay, and keep your prints nice and neat. Don't have a bunch of stuff overlapping. I think I'll get rid of that one. So if we have a square pattern, it would be reasonable to assume that this hole is in line with this hole. So the machinist would know, okay, come over 3.5, come down 1/2 inch for this one, down 5.5 for this one. That wouldn't be bad. That's a reasonable assumption. Okay. Next thing we need to do, we got to tell the machinist, what are we going to make this out of? So to find that, we can go back to our model, in this case. So I'm going to click on one of the views, I'm going to expand it, and I'm going to say open part. It bounces me back to the model. And I see in the materials, it's 7075 T6. Okay. When you get to your materials class, you'll know this is a grade of aluminum. It's a high zinc aluminum, really, really strong. This is actually about as strong as most carbon steels. AR-15 lower receivers made out of it. There's some nuclear components that are made out of it. Really good stuff. So if I X out and close the part, I go right back to my drawing, and I'm going to put a material note in. So under annotations, I'll click the note icon, and I'll say notes. My first note will be the material, and I'll say 7075 T6. Click in the graphics area and give it the green check. Did I put 2 of them in? Sometimes I've seen it will do this video artifact. There. So I hit the stop sign to refresh the drawing, and it went away. I'm not sure why it does that, but okay, it does.
Sorry, could you show me that again real quick, the material thing again?
Sure. Okay, so we're going to put the material in as a note. So I'm going to create the general category called notes. Note number 1 is material in all caps. Prints are always, always, always in all capitals. And we'll say, whoops, 7075 T6, 6. Click in the graphics area, the green check.
Alright, so like manually type it all in.
Yeah.
Okay.
You could link it up back to the model. I chose not to. It could be done. Okay, and I've got this video artifact over here. So I want that to go away. And I can rebuild my drawing with the little stop sign. So I'll hit that and it goes away. Okay, so I've got all my dimensions. I've defined my object. Notice that the drawing still says underdefined down here. That's fine. I'm not worried about that for drafting. But make sure that you size and locate every feature. That's the important thing. Okay, the next thing, we got to fill out the title block.
I had a quick question.
Yeah, go ahead, Sam.
When you're deleting the smart dimensions, for some reason, right-clicking, there's no delete option for me. Is there a different way to do it?
So I generally go to the extension line. See this line right here?
Yep.
That's weird. I thought in the previous versions it did. Okay, so I'm clicking on the extension line and I press the delete key. But yeah, you're right. That should have come up with a delete option.
So just left-click on the extension line and delete?
Yes. So I left clicked, press the delete key, boom, it's gone.
I don't know. It's not removing it for me.
Are you working on a Mac by any chance?
No.
Okay. Do you want to share your screen?
Yeah, sure.
Okay. It's yours.
So I'm just trying to delete this 0.5 here.
Okay. So go down and to your right to where it's extending below the arrow. Yep, click right there and press delete.
Nothing.
Nothing. Weird. Try putting a box around it and deleting it. A selection box.
Try exiting out of your smart dimension, like press escape and then try.
Nothing.
Are you pressing backspace, not delete?
Oh, gotcha. Yeah. Thanks for that.
I'm glad somebody came up with that one because I would have never thought of that one. All right, so let's see.
Thanks.
No problem.
Okay, so we got to fill out the title block. Obviously, my cool part is not what we want. So the drawing title comes from the description in the model attributes, as does the part number. So again, I'm going to go back to my model and I'm going to come right over here to the drawing manager window. I'm right clicking on the model and I'm going to say open part. We'll go to File, Properties, so that we go back to the attributes. We give it the part number that we want, so I pick something. 9876 is fine. We'll say we're going to use the dash for the initial release, no revision. The description, I'm going to say plate, comma, access cover. And let's imagine that we make it so that there's no vendor or vendor part number. I'll say okay, save it. And I'm going to close my model. Now when I come back to my drawing, I should see my drawing title has updated, my part number's good, my revision's good. Okay, so we still have to fill out the rest of these items. So sheet 1 of 2. Since this is going to be just a one-page drawing, we need to delete the second page. We can do it one of two ways. We can come down to the little tab down below, right-click and hit delete. That works nicely. I'll hit Control-Z to undo. The other way is you can come over here to the Drawing Manager, click on Sheet 2, right-click and do a delete. Either way, whatever works for you. So then for the rest of this stuff, just double-click in the entries. So in this case, I will change the date. Today is 10/6/20. The scale, I believe those were half scale. So it's 1:2. And sheet 1 of 1. Once you have everything changed, green check will accept the title block changes. And there we go. There is one thing I want you to notice about this. Okay, if we come in and we try to change these dimensions, they do not change the model this time because we did not use the design annotation. So for example, if I double click on that 6, nothing's happening. Okay, so you've got to import the design annotations if you want to have it compatible so that you can change it on the drawing and it goes back to the model. I don't care which way you do it. You know, if you set up your sketches so that it automatically makes the drawing view for you, great. I mean, you've saved a bunch of time. That's awesome. But certainly nothing I'm going to get crazy over and gig you on. Okay? So that's the first one. I would call that done, great, 100%, good to hand in. Any questions on that? Okay, lots of silence. That's a good sign, I hope. So let's close that out. And now let's go. What I'd like you to do is download the bearing holder. And it should look like this. That is class example bearing holder right in lesson 11. Okay, there's an important lesson to learn in this one, folks. That is, we never, ever, ever dimension to a hidden line. But sometimes there's just no way to do it otherwise, okay? That's when we put in something called a section view. And a section view allows us to imagine cutting through the part and being able to look inside. Once we can look inside, then we can dimension those features that would otherwise be hidden. In this part, I put a little snap ring groove right in here. Okay? There's no view that we can do with just plain old projections that will let us see that in a non-hidden line. So let's make a drawing of this thing. We're going to go through the exact same conceptual thought process. Make sure all of your views still move together. And I'm going to insert a projected view for the isometric. The isometric should always have the hidden lines turned off. So I'll click on the view. I'll come down to display style, do hidden lines removed. Now it looks solid. And I think I'll turn down the scale. Do quarter scale. There. That looks good. Okay. And these lines right here, these represent that snap ring groove that I was telling you about. There's no way I can dimension that without it being hidden. Okay. So let's actually saw the part in half so that we can see inside. We're going to say insert, drawing view, and we're going to choose section this time. And our section view dialog pops up. So we can cut it vertically, we can cut it horizontally, we can cut it angled to a face, and then you can do all these weird broken ones. For this class, we're just going to do horizontals and verticals. We can get into enough trouble with just those. So I'm going to choose a vertical saw cut. I'm going to come over to the front view, and I'm going to put my saw cut right on the center of that, the midline of that edge, right there. I'll say OK. I'm going to drag my view off to the side. Okay, it says CC. Well, that's a problem. Let's change that to A. I want to stress to you guys that whenever you make some kind of an extra view, something that's derived, something like that, always start at AA. If you start at CC, the reader is going to say, okay, well, where's AA and BB? I'm missing something. So keep it logical. So we'll just come over to the section view dialog. We'll go to the top and we'll change it to A. And I'll say OK. Now we have section AA. This is where we're making the cut right on this vertical line. And our eye is looking in the direction of the arrow. Now I can see that snap ring groove and I can actually dimension it. I have a cylindrical part, so I always put center lines on cylindrical parts. I'll come to the top, I'll choose a center line. There. And I'll put a center line over here as well, which you can't really see because it's under the section line. Okay, so same philosophy. You're going to give this print to a machinist. They're going to say, okay, great. How big a chunk of metal do I need to make this? Put on the overall dimensions first. We'll smart dimension it. We'll dimension the outside maximum diameter and the height. Okay, we've defined the chunk of metal that we need to cut this out of. And now it's a matter of just going through every single feature, sizing it, and locating it. This one's kind of easy because we have a cylindrical part. Always go to hidden or visible lines. Never dimension to the dashed lines. So in this case, some good choices would be, I'll choose the thickness of the flange. I do not dimension this, okay? You would not want to do something like that. That's double dimensioning. That's a huge no-no. We never do that because that creates conflict with our tolerancing. And also you risk errors, okay? So now we've got the height, we've got the flange thickness. Let's do the outer diameter down here. Whoops. Three and a half. And then we can come over here and put in the rest of our dimensions. Center bore of 3. Now we'll dimension our snap ring groove. Try to minimize the line crossing as best you can. And just think about, if I was making this, what is the information that I need to create that geometry? So I would come in from the front face of the part 1/4 inch. I would cut my snap ring groove to a diameter of 3 1/4, and I would make it a width of 70 thousandths. Okay, it's not too bad. So that takes care of the snap ring groove and the center bore. The next thing, we need to take care of our holes. Got to make sure we know how to make our holes. So we're going to do another hole call out. We'll say insert, annotations, and we'll come do a hole call out. There we go. And I get a really nice call out because I use the hole wizard. I'm pretty sure you would not get the 6x and the through all if you just did a cut extrude of circles. It would just say diameter 0.281. So a lot more information that we get for free using the hole wizard. And we'll choose our bolt circle diameter. 2 1/4 inches. Okay, I don't have to worry about clocking or anything like that because this hole is right on the center mark and it goes right through. The machinist is going to know to start right at here at 0 degrees and then go up and equally space them. So I've got all of my holes covered. Okay, so that looks pretty good now. Got my holes, my outside flange, got my maximum material that I need to make this thing. But I have not told the machinist what to make this thing out of. In this case, again, I'm going to go back to the model. So I hit the little triangle. I'm going to reopen my part. Okay, 1010 steel. That's good. So I'm going to put a note in that says 1010 steel. I'll choose the note command. And I'm going to say notes, always in all capitals. Material. .1010 steel. Okay, I want to get full credit on my homework, so I make sure that because I'm not going to use the second sheet, I'm going to delete sheet 2. Then I'm going to come in, I'm going to clean up my title block. Okay, this time I actually gave you guys the drawing title and the part number. So we don't need to fix that, but we do need to fix the date. So 10/6/20. I've actually forgotten what the view scale was. So it was, I'm clicking on the view. I'll come down to scale. It's saying use sheet scale, which is 1:2 or half scale. Okay. So I'll double click on the scale. 1:2. Sheet 1/1. And the only thing that I don't like at this point, one thing I'm going to insist is that you guys never, ever, ever put anything under the revision block. So this edge, it kind of intersects. Let's just pull this over a little bit there. And if you guys gave me this as a homework assignment, I'd be absolutely thrilled. It's got the center marks on all of the holes. It's got center lines on cylindrical bores. Nothing's double dimensioned. Everything's called out, got the material note, title blocks filled out. And you may be saying to yourself, how in the devil am I going to remember all of this stuff that this guy wants? Well, if you come back to the website, I created print examples. And if you choose the machined piece part print, there's all the stuff that you want to do. So just come right down this checklist and check this against every drawing that you ever turn in. And this will cover almost everything I could possibly ding you on. Okay, so use the examples as a reference guide. Okay, have you guys glazed over yet? Do you have enough coffee in your system? It's
I
very,
was
very,
wondering,
Yeah.
I just had a quick question about how would I go about deleting a center line? I ended up with center lines in all my holes on my face view.
okay. You should be able to just left click, press the delete button.
Oh well, I'll figure it out. Thanks.
Yeah, for some reason, different video cards work differently. And you know, you actually bring up a good point. I should have put center lines on these holes because those are cylindrical faces.
Oh, okay.
There we go. So I'd have to take 5 points off my own grade. Okay, somebody else had a thought, question, statement?
You said something about linking the dimensions to the model.
Yes.
How is that?
Okay, so we can import the design annotations or the design dimensions. Let's see. What's the best way to do that? So I'm just going to blow all of this away. Actually, we'll keep that. Get rid of that. I actually don't use it that much. Okay, so I'm clicking on what is now going to be my front view. So if we say import annotation and we bring in the design annotations, that brings in everything that was in the sketch that's parallel to what we're viewing. So now these are all linked back to the model. I'll say okay. Let's stretch that out. We'll stretch this out. Some of them are going to be useful, some of them not so much. So these are all the numbers from the sketch that I used to create this model. So for example, if I want to change the overall height of this part, I can double click on the 3.0, make it 3.5. And as soon as I update it, it will update the model and we have bidirectional associativity. So if you think ahead as you're creating your sketches and you think ahead to, okay, which views am I going to put on the paper? You can do a lot of your drafting right from the sketches by turning on the design annotations. So if you bring in the design annotations, it's bidirectional. If you just do smart dimensions, then you're just dimensioning what's on the paper. And it's not bidirectional. Okay?
You just go back over that one more time, just how did you get to the design annotations?
Sure. Let's get rid of the view. And I'm going to project the view down. So I'll create it off the top view. I'll put the view right in the front spot. Oops. I'll click on it and I'm going to say import annotation and choose design annotations. That brings in my sketch values. And if you've done it well and thought ahead, a bunch of these will be useful for your drafting.
Is there any way to hide the non-useful ones?
I've never tried to do that, to be honest with you. So let's see. Yeah, you could do it like that. So you could, so all I'm doing is right-clicking on it and choosing hide.
If you delete them now, it also deletes them from the part.
No, it does not.
Okay.
So if I delete this 070, that just deletes the note on the drawing print. Okay, it's still in the sketch. So again, if I want to change this back to 3.0, change it. I'll rebuild and I can go right back to 3.0. So, I mean, you guys can play with it. Honestly, I generally don't think that far ahead, in all honesty. I mean, it could be a useful tool, but I find that as the prints get harder and harder, or excuse me, as the models get more complex, it generally just gets cumbersome. But do it however it makes sense for you guys. Okay, so that was section views. That is how you cut the part to look inside and dimension objects that you wouldn't be able to dimension otherwise, because we never, ever, ever dimension to a hidden line. So section views are often used on internal features. So we'll get rid of that. And now let's try another one. Let's try this one called angle bar. And we'll talk about doing a different scenario, which will set you up in good shape for your homework. So on this one, looks like we're going to have just about enough time for this one. So I've got a piece of angle aluminum, and it's got 2 hole patterns in it. Thing about it is this is much, much larger than our sheet of paper. So let's make a drawing of it, see what happens. Okay. So the views actually don't look too bad. I'm going to turn down the scale on this isometric. Go to 1/16. Hidden lines are already turned off, so that looks pretty good. Oops, I can't move it over. I'll reproject it so I can move it. Go. Always turn off the hidden lines in the isometric. And go to 1/16 scale. Okay, here's one of my pet peeves, especially as an old guy. I'm looking at this model, and we could sit here and we could detail it all out, but it's really, really small. Okay, I can't see, this little bitty bit of detail that's going on. I can't see these hidden lines that are in here. But we actually have a special set of views for dealing with just this kind of a problem. When you've got a long, skinny part like this piece of angle iron, and maybe the ends are interesting, but there's not much going on in the middle, that is a perfect scenario for something called a broken view, where we get rid of this boring stuff in the middle and we just keep the interesting stuff. Then we can make it much, much larger, much more visible, and it's a much more readable print. So I'm going to say insert, drawing view, and break. I'm going to choose this view. I'll drop in my first break. I'll drop in my second break. I hit escape to end the command. Now look at my view. It became much, much shorter. And I can even grab these breaks and I can move them around. I'll get rid of this top view. And I want to reproject it. So when I reproject it, it reprojects it with the break. Okay, now I can turn the scale way up. So I'll use a custom scale, and maybe this time I'll go to, see what quarter scale looks like. Oh, shoot, I might even be able to go to half scale. I'm surprised that didn't reproject automatically, but we can take care of that. Okay, now this is a much, much nicer print. This I can actually read. And you're probably saying to yourself, okay, great. He just took out a whole bunch of material from the middle and he screwed up the overall length. Not true. So when I smart dimension it, I'll go from this end to this end. I get this little break symbol right here on the dimension, and I get the original 6 foot length. Very, very nice. Okay, so let's keep going with this thing. Let's fully dimension it. And this one, let's actually do the imported design dimensions. So I'm going to click on the broken view. I'll say insert annotation and the design annotation. And this one's actually a little bit cleaner. So I'm going to drag up my dimensions. I'm trying to minimize the amount of line crossing that I see. I'm going to delete that one. I'll delete that one. Okay. So I've located all of my holes now. Next, I need to say what size the holes are. So I'm going to put in a hole call out. What am I doing for time? Oops, running short. Whoa. Interesting. There's my hole call out. And very quickly, if I want to, I can turn on the design dimensions in the profile. Go. I don't have any dimensions in my top view. So if I don't have any dimensions, if it's not adding to the story, I can get rid of it. I need my material note. All capitals again. This was 6061 T6. Aluminum. And then I just need to come in and do the title block. Double click on the date. Okay, I've been having some video issues with filling out the title block, where I will type over it and it doesn't appear, and then I hit the green check and then it updates. So you guys may see that one as well. Whoops. Let's see, this was half scale. We fully defined it with one sheet. Delete anything that's not used. So get rid of sheet 2. And make sure that nothing is under the revision block, like this. And there you go. So that is a nice readable print of a long, slender object using a broken view. And you're going to see that on one of your homework problems. There's a long rod that you're going to have to do, and you'll need to put a break in it. Otherwise, it gets really teeny tiny. Okay, questions on that? It's pretty mundane stuff, guys. It's not super hard, but there's a bunch of new rules to consider. So just make sure you go down through the checklist before you turn in your prints. Okay. I will stay on. We're at the end of the class period. Anything anybody want me to go over with this?
If you could stay, I'm having issues still with that drawing, so we could troubleshoot that. That'd be awesome.
Yep, absolutely, Alej. Okay, then we will call the class here, and I will see you guys tomorrow, unless you want to talk about other stuff. So, I will stop sharing. Okay, you have the screen, Alej.
Okay, yeah, one moment. Let me just get Zoom on my PC.
Okay. And I think I'm going to end the recording at this point.